Hi guys, this is Pre-Algebra Lesson 1-2, Understand Rational Numbers. In this lesson, we'll be able to recognize rational numbers and write them in decimal form. Let's look at solve and discuss it. Calvin wants to customize his surfboard so that it is wider than the 82 model but narrower than the 92 model. What measurement could be the width of his surfboard? So we're talking about the width, not the height, okay? And if it's wide, the measurement is width. So if it's wider than 82 model, so this is the model that has the width of 82. The model number is 82. So the width for the model 82 is 22.5 inches wide, right? And model 92 is 23.1/4 inches wide. So if it's wider than 82 model, but narrower, so like smaller, than the 92 model, what measurement could the width of his surfboard? So he has a separate surfboard. Okay, so if it's wider than this one, but narrower than this one, what number could come between 22.5 and 23.1/4? It should be between these two, right? So a nice little whole number that's between these, is it 22, 23, or 24? In order to better understand, you can draw a number line. So if that is 22, and you have 23 here, 22.5 is right here. Okay, and 23.1/4, if that is 24, this is half, and that's 1/4. So that is right here. So if another surfboard is between these two, and you want a whole number, you can say it's 23, or you can do 22.3/4. Or 23.1/8. Okay, there could be numerous possible answers, but if you want a whole number, you can say it's 23 inches. It could be 23 inches. So let's write that down. Calvin's surfboard should be between 22.5 inches and 23.1/4 inches wide. The width of his surfboard could be 23 inches. Okay, so let's look at focus on math practices. Lindy's surfboard is 23.1/3 inches wide. Between which two surfboard models is her custom surfboard's width? How do you know? So if Lindy's surfboard is 23.1/3 inches wide, look at the widths here. Where does it lie between? So 23.1/3 is greater than 23. Is it greater than 1/4 or is it less than 1/4? If it's less than 1/4, it's between models 82 and 92. If 23.1/3 is greater than 1/4, it's probably between 92 and 102. So look at the number line again. 23.1/3 is around here. So it's really close to 1/4, but is 1/4 smaller or greater than 1/3 is the question. If you change this to decimal, 1 divided by 3 is 0.333 repeated, right? And what about 1/4? 1/4, 1 divided by 4 is 0.25. Exactly 0.25. Is 0.25 smaller or greater than 0.333, ... Yes. 2 on the 10th place is smaller than 3. So Lindy's surfboard is wider than model 92. So it's going to be between 92 and 102. Model 92 and 102. And let's explain how we know. So between the 92 and 102 models will be our answer. 23 and 1/3 is greater than 23 and 1/4 and less than 24. Because 1/3 is greater than 1/4. 1/3, 333 repeated, is greater than 1/4, 0.25. Okay, so you can draw a number line to compare them, and if they're too close, you can change them into decimals to compare them to. Okay, let's look at the next page. So throughout this lesson, let's think about how are rational numbers written as decimals. Example 1. Write rational numbers in decimal form. Terminating decimals. So decimal has different types. Okay, terminating decimals. Do you know what terminating means? To terminate. You might think of repeating decimals, but terminating is not repeating. Terminating means to end. So it means decimals that has an ending. Okay? So decimals that has an exact solution that ends at some point. Juanita is reporting on pitching statistics. Pedro's fastball statistics is 52/80. How can Juanita write the fastball statistic in decimal form? So how can we write 52/80 in decimal form? You will, in order to write fraction to decimal, it's fairly easy. You will literally divide the numerator by the denominator, because what does the fraction bars represent? It means division. 52 divided by 80 is literally 52 divided by 80. Okay? So you're literally going to divide 52 by 80. So you will eventually get 0.65 with a remainder of 0, which means this is a terminating decimal. Okay? A terminating decimal. Write this in your graphic organizer in the beginning of the topic. Terminating decimal is a decimal that ends in 0. So Juanita can write 52/80 as 0.65. Let's look at try it question. In the next several games, the pitcher threw a total of 384 pitches and used the fastball 240 times. What decimal should Juanita use to update her report? See if you can fill in the blanks by yourself and figure out the answer by yourself. Come back when you're ready for answer. Okay, are you ready? So divide 240 by 384. 384 doesn't go into 240. It's greater than 240, right? So you're going to start with 0 here. And then pull down the 0. And see how many 384 is going to 2,400 now. And you will get 6 times 384 is 2,304. Find the difference, bring down the 0, and see how many 384 goes into 960. 2 times 384 is 768. And the difference, 192, bring down another 0 by annexing a 0 here. And 384 times 5 is exactly 1,902, 0. So you get a remainder of 0. So Juanita should use decimal 0.625 to update her report. Convince me, how do you know that the answer is a terminating decimal? How do you know if it's terminating or repeating? How do you know if it's going to keep going or not? Because when you have a remainder of 0, then you're done dividing, right? It's just going to be 0, 0, 0. So you're going to end with 0. So when the remainder is 0, the decimal is a terminating decimal because there are no parts left to divide. And you're done. Okay. Let's look at the next page. Example 2. Write rational numbers in decimal form. Repeating decimals. So now we're going to look at repeating decimals. A class votes on whether to change their school mascot. How can you express the number of students in favor of a new mascot in decimal form? So in a class of 18 students, 5 voted to change their mascot. So we're going to have a fraction of 5 out of the whole 18 students. Okay, so write this in a decimal form. When we divide 5 by 18, we have 0.277, and then we'll notice that we get the exact same remainder every time, 14 and 14, and you're going to keep getting 14 as a remainder, and you're keep gonna say 7. You're keep gonna multiply 18 by 7, right? So that's a repeating decimal. Write this in your vocab graphic organizer. Repeating decimal has a decimal expansion that repeats the same digit or block of digits without end. So it's keep gonna repeat 777. The products and differences repeat. The remainder will never be 0. It's never going to end. It's keep gonna repeat itself. So the decimal form of 5 over 18 is 0.277 ... or you can write a repeating bar over the digit that is repeating. If you have 2 digits or 3 digits or more digits that are repeating, put a repeating bar over all the repeating decimals. Okay? So let's look at try it. What is the decimal form of 100 over 3, 100 over 5, and 100 over 6? Determine whether each decimal repeats or terminates. So divide 100 by 3, 100 by 5, and 100 by 6, and determine if any of them are repeating decimal or terminating decimal. Okay, pause the video and solve it by yourself. Come back when you're ready for answer. Okay, are you ready? So 100 divided by 3, you should get 33.333 repeated, or you'll write 30.3 repeated here. Okay? And 100 over 5, you will get 100 divided by 5 is exactly 20. So that is a terminating decimal, or rather a whole number. And 100 divided by 6 is 16.6666 repeated. So you will have 16.6 bar here. Okay? So this one is repeating, and this one is terminating, and this one is repeating. Okay, let's look at example 3. Recognize rational numbers in decimal form. Explain whether each of the following is a rational number. Negative 6.382. This decimal terminates. It doesn't have a dot, 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 or a bar that says it's repeating. So this is a rational number. Okay, the digits, let's look at part B. 1.539981. 1 repeats, right? The digits 8 and 1 repeat infinitely. But this could also be written as a fraction. So it's a rational number. Okay. And part C. 0.43524982 dot, dot, dot. Does it have a pattern? It is not repeating or it is not terminating. So if it's not neither of those two types of decimals, it is not a rational number. Yes, it is a decimal, but it doesn't go into the category of repeating decimal or a terminating decimal. So in this case, this is not a rational number. Okay? So if it terminates or if it repeats, it is a rational number. If it doesn't do any of those, it is not a rational number. Okay, look at the try. Is negative 0.3 repeated a rational number? Is 3.14, 144, 1444, 14444, dot, dot, dot a rational number? Explain your reasoning. Okay? Is the first one a rational number? It is a repeating decimal, so yes, the decimal value repeats. So negative 0.333 dot, dot, dot is a rational number. Or let's do this. Okay. What about 3.14, 144, 1444, 14444, dot, dot, dot. It does have a pattern, but is it repeating? It seems like it's repeating. It's repeating patterns, but it's not repeating the same digit, right? It's not repeating 14. It's not repeating 144. It's not repeating 1444. It's just repeating 1 and 4 in different number of digits, right? So it does have a pattern, but it's not a repeating decimal. Okay, it does not terminate or repeat, so it is not a rational number. Okay, so be careful with these type of decimals. It does look like it's repeating something, but just because it has a pattern doesn't mean it's a repeating decimal. Okay, it needs to have an exact amount of the same digits that are repeating. If not, it is not a repeating decimal. Okay, keeping that in mind, let's wrap up our lesson. So, to convert from the fraction form of a rational number to its decimal form, you're going to divide the numerator by the denominator. You literally divide 3 by 4 and 1 by 6 to get the decimal form. The decimal form of a rational number either should terminate in zeros or eventually repeat. If it's neither of those decimal, it cannot come from fraction. It cannot be written as a fraction, so it's not a rational number. Okay, guys, that was lesson 1-2, understanding rational numbers. Well, if you have any more questions, please ask Ms. King in class. We'll continue with the next lesson in the next video. Thanks. Bye.